Okay, think about your computer right now, or your phone. They're doing millions of things at once. The internet itself is a storm of activity. So how on earth does it all work without just collapsing into total absolute chaos? Well, it's because of this hidden rulebook, a really special kind of logic that actually governs the flow of digital time. Let's dive in and see how it works.
And this quote from our source material really just nails it, right? Our digital world is this hurricane of things all happening at the same time. And taming that chaos, that required inventing a whole new way of thinking. It's called temporal logic, and it was literally built from the ground up to bring order to that storm.
So, let's start with that central problem. How do you tame digital chaos? You can think of any device you use, really, as this super busy city just humming with activity. And without a master plan, without a set of rules, what do you get? You get gridlock, you get crashes, you get errors everywhere.
So here's the breakdown of what engineers call concurrency. And the analogy I absolutely love is to picture a kitchen with like 1,000 robot chefs, all trying to use the same oven at the same time. Without a schedule, without some kind of logic, you just get chaos. We're talking burned food, broken robots, the whole mess. That is exactly what happens inside your computer without a logic to manage who does what and when.
All right, so how in the world do you solve a problem like that? I mean, you need a language that's way more sophisticated than just a simple yes or no. You need a language that actually understands concepts like before, after, during, and, crucially, eventually. You need a logic that's built specifically for time itself.
And that, right there, is where temporal logic comes in. It's basically a formal rulebook for time. It lets engineers write these incredibly precise instructions, like, hey, after a user clicks buy, you must eventually show a confirmation screen, but before that, you must never, ever charge their card twice. You see, the order of events is absolutely everything.
And look, this is not just some dusty academic theory, okay? This logic is the invisible backbone of the technology we use every single day. It's running in the operating system of your laptop, it's in the protocols that make the internet work, and it's even used to verify the physical computer chips inside your devices. It's quite literally everywhere.
Now, I know what you're thinking. A rulebook for time sounds insanely complicated. And yeah, it can be. But what's so cool about it is that it's all built on two, surprisingly simple but super powerful core ideas. These are the two fundamental rules of concurrency. Okay, so everything, and I mean everything, hinges on this difference between safety and liveness. Safety properties are your never rules. A bank transaction must never be left half-finished. They're what prevent total disaster. Liveness properties, on the other hand, are your eventually rules. Your email must eventually be sent. They're what guarantee the system actually does its job and makes progress. And you absolutely, positively need both for any system to work right. Okay, but here's where it gets even more interesting. What happens when the future isn't just a straight line? I mean, in any complex system, there are countless possible outcomes that could happen based on what a user does or if there's a network delay. So how do you write rules for a future that can branch out in millions of different directions?
This slide just illustrates the two main approaches so well. The first one is linear time logic, or LTL, and it's kind of like a single train track. It reasons about the one future path the system is on. But the second one, branching time logic, or BTL, now that's like a massive rail yard with countless switches. It can reason about all possible futures. And this lets you ask these incredibly powerful questions like, is there any possible path, no matter how unlikely, that could lead to a total system crash?
So, when you put all these pieces together, you start to see that temporal logic isn't just some dusty old rulebook. It's more like an unseen architect, you know? It's carefully designing the very flow of information in pretty much every piece of technology that we rely on.
And the really crucial part here is that this isn't just guesswork or some good ideas. These logical systems are built axiomatically, which means they're founded on pure, hard mathematical proof. They're designed to be sound and complete, which is just a fancy way of saying engineers get a rock-solid, reliable way to prove that a system will behave exactly the way it's supposed to. So, the next time you unlock your phone or send an email or do pretty much anything online, just remember this silent guardian. It's this logic, working constantly in the background, conducting this chaotic dance of millions of digital processes. It's what makes our modern world not just possible, but actually reliable.
And that really leaves us with a huge question to chew on, doesn't it? We invented this whole logic to tame the chaos of the technology we have today.
But as our systems, from AI to the Internet of Things, become exponentially more complex, what new rules for time will we need to invent to keep our future from sliding back into chaos?